Chapter 11 deals with ideal gases. That is, the simplest form of how we treat gases in chemistry and science. The ideal gas law is an ideal equation because we don't have to look up many parameters that are unique to each gas. Rather, the ideal gas law is a universal law which doesn't take into account things like size of the gases or if they have intermolecular forces. What I'm going to do is I'm going to break this chapter into two videos. One dealing with the equations and all the math that are involved when working with gases, and then this video which deals mainly with the properties of gases. So let's talk about some of those properties. What do we know about gases? Well, we know of all three phases, gases have the lowest density. Gas molecules are free to move wherever they want, that is to say they expand to fill the container in which they reside, and besides having low density, they are also highly compressible. Gases form homogeneous mixtures almost immediately when they're introduced into a container. When we talk about gases, we talk about gas pressure. Pressure is a measurement we use which describes the force applied over an area. Atmospheric pressure is the pressure we experience at any given elevation. That is, it changes depending upon how high up or how far below ocean level we are. We tend to refer to atmospheric pressure as being 1 atm. That is the pressure you experience when you're sitting at the ocean. But there are other ways of reporting gas pressures. Some of those include torr, or millimeters of mercury, which we'll talk about in a second, or kilopascals. These are all legitimate pressure measurements and unique to different fields of science. What we do have in common, though, is something known as standard temperature and pressure, and that refers to a gas when it's at 0 degrees Celsius, or 273.15 Kelvin, and 1 atmosphere pressure. It's referred to as standard temperature and pressure, or STP. At STP, all gases would occupy a volume of 22.4 liters. Doesn't matter what the gas is, if the gas is behaving like an ideal gas, then it's going to have a volume of 22.4 liters at STP. But let's talk about this millimeters of mercury and torr for a second. Well, it was found that an evacuated tube, when placed in a solution of mercury, the mercury would rise up 760 millimeters at ocean level. Thus, the earliest pressure measurements were made by how high the mercury moved up the column and how many millimeters it was. It's still a legitimate measurement of pressure, and it's based off of the Torricelli barometer. This was later referred to as torr rather than millimeters of mercury in honor of Torricelli, and is still used today.